Welcome to the next topic, topic C, dealing with primes. I'll have a few videos on this one. The first video is on primes, composites, and relative primes. All right, so we've got some definitions, then just a couple basic problems. All right, first definition of a prime. Okay, so it is a natural number with only two positive, distinct divisors of 1 and itself. So an example would be 7, because 7 is 1 times 7, there's no other divisors, just two positive distinct divisors, 1 and itself. Composite. Composite is a natural number with some other positive divisor besides 1 and itself. So an example would be 6, because 6 equals 1 times 6, well, that's not showing it, but 6 is 2 times 3. So I did find a different positive divisor besides 1 in itself. All right, relatively prime or coprimed. So these are natural numbers with no positive divisor in common besides 1. Okay, so an example would be 8 and 13. 8 is not a prime number. 13 is a prime number. However, these are relatively prime because the only common divisor they have is 1. 8 is 2 times 2 times 2. There's no 2's in there. 13 is 1 times 13. There's no 13's in there. 8 is also 2 and 4 and 8 and 1. So that would be an example of two relatively prime or coprime numbers. Okay, then the question is, what is 1? Is it prime? Is it composite? Or is it neither? All right, well, let's take a look. 1 equals 1 times 1. In order for it to be prime, it's got to have only two positive distinct divisors, 1 in itself. That word distinct. That means different. Okay? So 1 and 1 are not distinct numbers, they're the same. So it's not prime. It's not distinct, so not prime. In order for it to be composite, it's got to have some other divisor besides 1 in itself. Well, it doesn't have that. So it's not prime, it's not composite. So the answer is 1 is just neither. It's not prime or composite. Okay, so now I've got two quick problems. I'll erase up here just to get a little bit more space. And I'll work on problem E first. Then I'll erase that. And we'll do problem F. All right, E. Find the smallest composite integer relatively prime to both 30 and 91. Okay, so let's find the divisors of each. So 30 is 3 times 10, which is 2 times 5. 2 times 3 times 5. That's the prime factorization. 91. After a while, you'll remember that 91 is divisible by 7. 7 goes in there once, 7, 21. So 7 and 13. Okay, so I want to be relatively prime, so I can't have a 2, 3, 5, 7, or 13. And I want to be the smallest composite. So let's just list down what the primes are. 2, 3, 5, 7, 11, 13, 17, 19, 23, etc. So I can't be 2, I can't be 3, can't be 5, can't be 7, can't be 13. I can be 11. And it says it's got to be a composite integer. So I won't have it be 11, I'll have it be 11 times 11. I could go 11 times 17, but that would be larger. They said the smallest. So 11 times 11 equals 121. That's composite, and it's the smallest composite integer, which is relatively prime to both 30 and 91. It's got factors of 11, whereas those numbers do not. Okay, and now the last problem, problem F. Let me erase this. States, find the smallest composite integer which is not divisible by the first 8 prime numbers. Again, get in the habit of pausing the video, stopping the video, checking for answers later. So let's write down the first 8 prime numbers. I just had it. So 2, 3, 5, 7, 11, 13, 17, 19, 1, 2, 3, 4, 5, 6, 7, 8. And the next one is 23. So it's not divisible by any of those, but it can be divisible by that one. And again, it's supposed to be the smallest composite, so why don't we again just go 23 times 23. 9, 6, 6, 4, 529. And there you go, how to deal with primes, composites, and relative primes.